Welcome to this GCSE question. It's a problem-solving, evaluating type of question. You've got to justify or comment on Callum's statement that the perimeter of a rectangle with a diagonal of 10 centimeters is always between 20 and 30. Okay. Now, we're going to look at this in several different ways, but I'm going to start by I've just drawn a few ideas here. So we know that we've got this rectangle with side lengths A and B, and the diagonal is always 10. Okay, that doesn't change. Okay, so I've done three different versions here. We could have this one on its side and make a very tall, thin one. We could have B very small, so it's almost flat. Okay, the middle ground is like a square where A and B would be equal. Okay, so there's a whole range of possibilities, but the diagonal must always be 10. Now I'm just going to take this triangle out here. So this still has a length of 10, a hypotenuse of 10, okay? But I'm just going to tip it over like that, okay? And it's easier to see that way. So I'm just going to label on this the A and the B, and this could be the A. It doesn't really matter. The A and B are the two short sides, so that would be the A there, of course, and that would be the B. This number down here would be 10, because that's the hypotenuse of the triangle, because I've turned it over. Okay, so that should be 10 there. All right. Now, I think most people can see that if that line there is 10, in order for a triangle to exist, okay, the right angle is up here at the moment, but in order for that triangle to exist, A plus B has to be greater than 10, okay, because if it was equal to 10, I mean, suppose it was 3 and 7, then these two sides would just drop flat onto the triangle, onto the base, okay? And if they were less than 10, if they added up to 9, that would happen again. So they have to be more than 10 in order to meet without falling onto the floor, if you like. Okay, so that's kind of logical. But let's have a look at some algebra to explain this a bit better. Okay, so what I'm going to do first is I'm going to write down what we're talking about here. We're saying that, well, if we take A plus B to be half the perimeter, okay, we're looking at this, the perimeter of the rectangle being a minimum of 20, which means that A plus B must be a minimum of 10, because that's half the perimeter, okay, because the perimeter is made of 2A and 2B, isn't it? So A plus B, we're saying, must be greater than 10 by our kind of logic and intuition and the little explanation I've just given here. And because A and B are both positive numbers, okay, because they represent lengths, if we squared both sides, we would say that A plus B squared, okay, must be greater than 10 squared, which is 100. Okay. Now, A plus B squared does not mean A squared plus B squared. It means A plus B times itself. Okay. And this is very important. So A plus B times A plus B. Okay. We're claiming has got to be greater than 100. Okay, so let's multiply that out using FOIL, first, outer, inner, last. Okay, we pair off the letters like this. So A times A is the first term. Okay, the outer term is A times B, the inner term is B times A, or A times B, and the last term is B squared, you see. So when we combine those four things together, we get A squared, okay, plus AB plus AB, which is 2AB, and we also get B squared, and we're claiming that is greater than 100. Okay, and I'm just going to change the order of that. You'll see why in a moment. A squared plus b squared plus this 2ab must be greater than 100. Okay, now we're now going to consider another aspect to this, which is Pythagoras' theorem. Okay, now Pythagoras' theorem would tell us that for any of these situations here, that a squared plus b squared equals 10 squared. Okay, so by Pythagoras we know that a squared plus b squared equals 100 exactly. Okay, 10 squared. All right, and that must be true for any right angle triangle, which is what's going to happen if you take split the rectangle down the diagonal. Okay, so we can confidently say that's true. And here we're saying a squared plus b squared plus this thing 2ab must be greater than 100. Well, what we need to be clear about is for that to be true, we need to be sure that a and b are both positive numbers. Okay, because if a squared plus b squared equals 100, if we add anything to the left-hand side that's positive, however small it is, it will cause it to be greater than 100. Okay, now we can say that a and b are both positive because they both represent lengths of lines. So whatever happens, we can be sure that a squared plus b squared plus 2bab is greater than 100. Okay, so I'm putting that statement with this one, and you can see the comparison, and we need to qualify that by saying since A and B both positive, okay, or both greater than 0. Okay, because if they weren't greater than 0, we wouldn't have lengths. Okay, so that's how we can conclude for sure that the perimeter can't be lower than 20. Okay, that's the first part of it, because you see a and b make up half the perimeter, which is 10, which is greater than 10. All right, and 2a and 2b make up the whole perimeter, which must be greater than 20. Now what about this 30? Well, this one really comes from the fact that you can show quite easily using a process called calculus at A level that the maximum perimeter would occur when this is actually a square. All right, but it's pretty easy to see, because if you sort of swing this 10 length around from the floor, when you've got a very, very small, thin rectangle, as you swing it up, the perimeter gets bigger and bigger. And then as you come to the top here, it gets very thin and vertical until it disappears. And the maximum perimeter, and for that matter, the maximum area, occurs when this angle is 45 degrees and this is actually a square. Okay, now, so we can say that the maximum, so we'll maximum perimeter, okay, when A equals B, because that would be a square. All right, and so we could say that both the length and the width of the square, if you like, are the same. So we could imagine this to be A and 10. So by Pythagoras, a squared plus a squared equals 10 squared. Okay, so 2a squared equals 100. Okay, a squared therefore equals 50. And remember, a and b are equal, and a therefore equals root 50. Okay, now the root of 50 is slightly over 7 because the root of 49 is 7. The root of 50 is approximately 7.07, and then it goes on. Okay, and therefore the maximum perimeter is 4 times root 50. Okay, and that's going to be about 28, isn't it? 4 times that, but I'm just going to write it as 4 root 50 as an exact number, and then which is less than 30. Okay, so we've shown that it's less than 30, and we've also shown that it's greater than 20. Well, we've shown that the half the perimeter is greater than 10, so therefore the perimeter is greater than 20. Now, that's a very algebraic approach to this kind of problem. Okay, it's just an interesting piece of algebra. Okay, so hopefully you've enjoyed that, and thanks for watching.